Hello, everyone. My name is Stephen Hardy. I am Editorial Director and Associate Publisher of Broadband Technology Report, and it's my pleasure to welcome you to today's BTR webcast on the benefits of network monitoring. Our webinar today is sponsored by VX, whom we thank for their help in making today's event possible. So it might seem that the benefits of network monitoring are pretty obvious. You monitor your network because you want to know when something goes wrong, hopefully before things get too far out of hand. But it turns out that network monitoring, and more specifically the right approach to network monitoring, has a variety of benefits that affect the bottom line, as well as your ability to keep. This is particularly true, I think, given the current requirement and technology trends that are shaping networks today. So in this webcast, we'll address this topic via a pair of presentations. In addition to my role as moderator, I'm going to be kicking things off with my picks for the 5 key trends that will affect network monitoring, touching on those catalysts for network evolution that I just did. And then you'll hear from Cyril Morel, who is the President and CEO of VX, who will address the main topic of our discussion on network monitoring benefits. But before we begin, let me provide some info for you regarding our webcast setup. First, if you're not happy with the size of your presentation screen, you can change it either by clicking on the Maximize icon on the top right of the slide window, or by grabbing the bottom right-hand corner of the slide window and dragging it with your mouse. Next, you should also see a row of function buttons at the bottom of your screen. One of the most useful of these should be the Q&A function. I believe has already been enabled for you in the form of a submission button next to that screen. I'm hoping you'll feel free to ask questions at any time during our presentation today. To submit a question, all you have to do is click on the Q&A box, type your question in the submission button. Cyril and I will be happy to answer as many questions as we can after we finish our 2 presentations. We don't plan to reveal the names of anyone whose questions we choose to answer today, so you'll be able to participate anonymously if that's important to you or to your company. Now, if you run into a technical problem during the presentation, there are 2 things you can do about it. First, you should see a help button among those icons at the bottom of your screen. So in the event you're having audio or other problems, you can click on that help button, and you'll find a list of solutions to the more commonly encountered problems, although we don't anticipate you'll have any. Second, though, if the info there doesn't help you out, you can call for assistance via the Q&A tool. Just describe your problem, hit the question submission button, and Sarah, today's webcast technician, will help you out. Next, if you know of someone who might enjoy seeing this webcast themselves later, or you just want to review the presentation yourself at some future time, this webcast will be available on demand from our webcast archive for the next several months. We'll send you an email message with a link to the archive when it's available, which should be within the next 24 hours or so. The archive version of the webcast also will be accessible from the archive section of our website, which you can reach via our homepage at btreport.net. Just look for the word webcast above the main navigation bar. And finally, either now or at any point during our webcast today, you can download a copy of the slides via the resource button, which is the one at the end of the row of buttons that looks like a green folder. And with that, let's begin with, as I said, what I think are the 5 major trends that will shape network monitoring's evolution. The first of these, of course, is the advent of new emerging service requirements. Multi-screen and OTT clearly are 2 that have been getting a lot of attention recently. And of course, we recently did a webinar on testing multi-screen environments, which of course you can also find in the on-demand library at the website. So with multi-screen, as the name implies, we're looking at a variety of devices for accessing services, and those devices are clearly being supported by a variety of different network types. And so therefore, your network monitoring system obviously is going to be affected by potentially increasing complexity in terms of having to keep track of a piece of content or a particular experience, as potentially it's hopping from the fixed line TV set to some sort of mobile device. Over the top, of course, brings in its own set of challenges. Obviously, to some degree, it becomes something of a challenge for the operator in that the service isn't originating on your network using your facilities, but since it's being delivered using your infrastructure, there's a real good chance that the end user is going to hold you accountable for what it looks like. Cloud-based services, both in the business realm and in the residential domain, are becoming more and more popular, with virtualization being used more and more for things like cloud-based DVR and whatnot. The fact that we're now virtualizing certain services or certain functions presents some challenges that I'm going to go into a little bit later, but obviously the issue here is that things that potentially might have been hardware-based are now moving to software, or things that may have been within a particular piece of hardware, say at the customer premise, is now being housed at a centralized facility. And so keeping track of where those functions are and where they originate is something that a network monitoring system is increasingly going to have to be able to keep track of and adapt to. We're talking about expanding business services potentially within that context of cloud-based services. That means, again, kind of a different, potentially anyway, different standards in terms of performance and requirements and whatnot. Service level agreements need to be established and maintained, and therefore clearly that's something that a network monitoring system has an important role to play in. And of course, we're potentially talking about a variety of different services over the same network, all of which may have different requirements as well that have to be accounted for. And then kind of a subset of business services, or at least non-residential services, is mobile backhaul, which is something that a lot of operators are looking to support. Again, a whole different set of requirements, different protocols, different kinds of traffic that potentially have to be monitored as well. So one of the outcomes of all these emerging different services is that frequently operators are finding themselves operating multiple network architectures that potentially a network monitoring system has to cover. On the residential end, I mean, you can see them here. On the residential end of things, regardless of whether you're using a traditional HFC network or you have started implementing fiber to the prem, even within those two main categories, there are a lot of different options and architectures that are evolving with new additional technology in the HFC world. Of course, CCAP now and DOCSIS 3.1 in the very near future are things that are going to be rolled out. Obviously, you don't just snap your fingers and the technology is deployed, so there will undoubtedly, in most instances, be phased rollouts. So part of your network will be CCAP enabled, part of your network will not, and that means your network monitoring system has to be able to account for those differences. Same thing with DOCSIS 3.1. So you'll have some parts of your network on 3.0 or earlier potentially as you're rolling out 3.1. In the fiber of the home or fiber of the premise realm, of course, as you can see, we've got the different flavors, EPON, GPON, potentially 10 gig PON. There are some operators out there that are starting to look at NG-PON2 or WDM-based PON, TWDM-based PON. RFOG, of course, is out there, as are other point-to-point kinds of architectures. All of these operate differently, and a network monitoring system has to be able to keep up to speed on the different ways that these architectures operate. And of course, there are business networks as well. Most of these, of course, are tend to be point-to-point, but WDM-based. And again, network monitoring has to keep track of all that. So depending upon how many of these different options are in your network and how broadly based you're hoping your network monitoring system can extend, so that you're not operating a whole bunch of different network monitoring systems for a whole bunch of different networks. The network monitoring system obviously has to be much more flexible and be able to keep track of all these differences. So obviously that is a challenge, and so there is a drive towards converging some of these disparate networks and disparate service types over the same network. So we're seeing this particularly as fiber gets deeper into the network, and also DOCSIS 3.1 with the bandwidth that it will be able to support also offers the opportunity to carry a greater variety of services over a hybrid fiber coax network. Obviously, this is a good thing as far as simplifying network operations, but in some ways that potential challenge I was talking about before in terms of multiple services over the same network, all of which have different requirements and different parameters that have to be accounted for, potentially becomes even more acute. So again, your network monitoring system has to be able to adapt to these sorts of things and keep up with the evolution of your network strategy. Fourth, we're seeing an increase in network intelligence, and this is a good thing, obviously, for network monitoring. We're seeing more systems being offered that have at least some degree of built-in diagnostic or data gathering capabilities. In the fiber to the home space, we're seeing, for example, systems that supposedly have a basic OTDR functionality that can help you locate faults if indeed any exist, or help you to confirm that your new service turnup is or your new network deployment is working the way it should, at least from a basic level. So obviously that's something though that would plug in best with a network monitoring system. And as I said, there are also other aspects of data gathering going on with some of the smart devices that the end users are using, as I list here. Another interesting thing we're starting to see roll out more frequently are smart optical transceivers. And here I'm talking about optical modules that do more than just convert light to electricity and vice versa. The smart transceiver has a fairly long history, starting with the first devices that incorporated some basic fiber to the home ONT functionality to create what was affectionately termed PON on a stick that you would plug into your network interface device and therefore be able to connect a customer CPE that was designed for a traditional network into a PON network. We've seen more and more kinds of intelligence being added to different kinds of transceivers, including the ability to do some degree of diagnostics and whatnot, or report faults that a network management system potentially would be able to take advantage of. And so one of the things that I think we're going to be seeing in the future as well is network monitoring systems taking more advantage of some of this increasing intelligence to not only keep track of what's going on in the network, but potentially being able to help with diagnostics and whatnot as well. And then finally, in terms of the number 5 trend is the trend towards programmable networks. And we talked a little bit about cloud networking a few slides back. It's the first step, but of course SDN and NFV are the two big trends that everybody's talking about in terms of really bringing this programmability to networks. So here what we're talking about, of course, is a drive to make networks more open, more flexible, and to decrease both the cost and the time it takes to roll out new services. Also, some side benefits in terms of preventing vendor lock-in and whatnot. So these are all wonderful things that are being promised. We're now in the initial stages, obviously, of figuring out exactly how these rollouts are going to happen, what makes sense to virtualize, and what doesn't. But as you can imagine, this move will have to be done within the context of existing operating systems and existing network monitoring functions. And also, it's going to be an evolutionary approach. Again, as we were talking about before, you can't just snap your fingers and voila, you're in an SDN NFV world. So, for example, what that means is that in all likelihood, in many of the networks, you're going to end up having SDN and NFV enabled services riding over the same network alongside more traditionally provided services, all of which are, and then again, that network infrastructure is being overseen by a network monitoring system. So, if there is a change requested or enacted via the SDN ecosystem, then obviously you'll want your network monitoring system potentially to help you ensure that or confirm that the change took place as required. But the other thing too is that it has to be done in coordination with the network monitoring system, so that, for example, if the monitoring system is tracking a certain amount of traffic and the SDN cloud has switched that traffic to another link or whatnot, you don't want your network monitoring system suddenly sounding an alarm because it didn't know that was supposed to happen. So clearly, what we're going to need here is an ability for network monitoring systems to work with the SDN cloud as we move forward. The other interesting thing that I think people, particularly in the test and measurement world and to some degree the monitoring space as well, are trying to get their arms around is the whole concept of, as we virtualize functions, how do you keep track of them? How do you test them? In some instances, how do you even find them? One of the things about virtual network functions, of course, is that they can reside anywhere on the network, and you can move the location of that function from place to place or server to server. So, if something is going wrong, or you want to assess the performance of a particular function, one of the most basic things you have to do is find it. So, of course, when things were pretty much hardware-based, that was pretty easy. You knew where the box was. You could plug into the box. You could monitor the box, and that was pretty well understood. So the question now becomes, as things become virtualized, how do you oversee them? How do you interact with them? And so this is something that I think that network monitoring systems are and the providers and obviously for you folks in the networking domain, the operators are all going to have to get their arms around as SDN and NFV get rolled out into the network. So in summary, many aspects obviously of the network are still in flux, and as I was just sort of suggesting, as programmability becomes more and more employed in networks, that idea of flux or changeability actually is going to be kind of embraced as a benefit as opposed to a challenge, and therefore the network monitoring capabilities in the network are going to have to be in step with that. As we said, more information in the network is being generated that potentially could be leveraged to keep up with this more rapidly changing environment. And so it's kind of bottom line, while the challenges to adequate network monitoring are growing, the elements of a solution are beginning to emerge. And so along those lines, I am now going to turn the con over to Cyril Morel, who, as I mentioned previously, is President and CEO for VX. In this role, he is responsible for global operations, product development, and technology strategy. With nearly 20 years in the telecommunications industry, he's held a variety of management positions, including Vice President of Product Marketing for Sunrise Telecom, Inc. Cyril co-founded VX in 2006 and serves as a member of the Board of Directors. He holds a Master of Science degree in Electrical Engineering from San Jose State and a Master of Science in Telecommunications Engineering from ESME in Paris, France. He will be now reviewing the benefits of network monitoring. Cyril?
Thank you for having us, Stephen, and thank you for the introduction. So first thing that we're going to do is a quick agenda of what we're going to talk about. So I'm going to give some basic concepts so we kind of fall on the same playing level in terms of what we're talking about when we talk about network monitoring. And one of the big things that any service provider has in mind is if I spend so much money into a monitoring system, because normally monitoring systems are not on the cheap side of the house, can you reduce my truck roll? So we will talk about that. Then one of the things that you mentioned in your presentation, Stephen, is that actually there's a lot of data that is available now on the device themselves, and that's actually allow you to do proactive strategy. So we'll talk about how we can deal with this network issue by being proactive versus being reactive. And then, of course, the big thing is now you have a lot of data, and what do you do with that? Because when you see all these ones and zeros coming from your monitoring system, if you don't have the right intelligence to be able to extract the right information, but actually you spend money for nothing because you have no data. So let's look at the basic of a monitoring system. So if you look at first of all, you have a network. So your network that you want to monitor. So your network can be mono technology, like a pure Ethernet type network, or it can be multiple technology, where you have wireless piece, you have Ethernet piece, you have GPON, DOCSIS 3.1, and so forth. This is like what I will call on the technology that rides on your network. Your network itself can also be hybrid. For example, the best example for that is something that is very dear to my heart is the cable TV world, where you have part of your network that is fiber and part of your network that is RF, and they work together to deliver the service to your customer. And that brings a lot of different problems that you need to look for when you monitor. And of course, your network can be residential and business. If we look in the past, there were a lot of focus done on the business side of the house because these are normally high bandwidth customers, high pay customers with SLA agreement. On the residential side, it was more best effort scenario where you get the service, if you get 20 meg, you get 20 meg and you should be happy with it. Well, now with the competition and everybody trying to get your little data coming from your home, there's much more service level agreement going on the residential. The biggest problem from a service provider is when you go to residential, you don't have 10,000 customers, you have million customers. So the problem of monitoring that is even bigger than when you were just focusing on the business. The second thing that you can look at when you do monitoring is active network devices versus active probes. And that is actually has been a very big debate that if you come from the field of the operation side of the house, you will think active probe is better because you like to have a device that is independent from anything else. If you're coming from the IT side of the house, then you want to save on cost and you think the active network can give you all the data that you want. And I will mention that a little bit more detail on my next slide. Then, of course, after that, you have the servers that are going to collect all this information, and they're going to be servers that do collectors and servers that process, do analysis, and generate the alarms, because technically, if you monitor your network, at some point you will have alarms if you have problems. So the big debate is active probe versus active network devices. And when I mean active network devices, I take them as a whole. That could be the CPE that sit at the customer house or businesses. It could be the bigger router or the bigger switches that you have in your head end or central offices. It could be your SFP that you mentioned before. It could be your power supply that you have to power your line into your network. It could be a lot of different things. I just treat them as one whole that is your active network device. And the main thing of these devices is actually they're already deployed and they are paid for because you're using them already in your network. So you don't need to spend extra money to put extra probes. So that's a big advantage of looking at active network devices versus active probes. The only problem is even though there's an evolution and a trend to add more and more and more into these devices, they do only provide partial analysis. And keep in mind that any active network device, its job is not to monitor the network. Its job is to carry the network traffic from point A to point B. So that's revenue. When you start to take resources from these devices to actually analyze your network, then you have cycle of CPU that are used to do something that is not money generating, and then the CFO of your company, if you're a service provider, might have a little heartburn with that. And they're not always on. What I mean by that is if you have a fiber cut and you cannot talk to the device at the end of the line, it's not going to be very useful for you to have only active network devices. If we look on the probe side, well, the problem is always a problem of money. The first thing is it requires additional investment and resources. So now you need to have a budget to be able to acquire these probes or these devices that you want to put in your network to monitor. The beauty of that, though, is these things are custom-made to monitor the network based on the parameters that you want to see, and they are real-time. And they provide you the health of your network real-time with no downtime. And they are normally what we call non-intrusive if you only look at monitoring. If you start to go with RTFS system that is a remote test fiber, you might have some signal that is generated into the network, or there's also, when you talk about Ethernet, you can use the network extra bandwidth to send certain signal into your network to monitor. So I don't want to say that it's not always non-intrusive. That's why I put the quote-unquote. But normally we try to be non-effective to the service that's right on the network when we do monitoring. Now, if you ask me personally, if you ask Cyril, what do you think? I think actually the best approach is to combine both, because they both have value. Having your active network devices give you an enormous amount of data and actually visibility on every point of your network. And these data are very important to actually combine them with an active monitoring probes that actually both of them can see different things. And if you combine them together, then you have a very, very great, powerful network monitoring. And actually one of the best examples that I know to date that has been in place at several service providers is proactive network maintenance from CableLab that has been embraced by the cable TV industry, and it's a really, really great tool. So what do you get from monitoring? That's always a question that people say, okay, great, I'm going to spend $5, $10, $20 million to put all these probes, servers, and so forth, involve all these people in my company to do that, and what do I get? So technically, from the net monitoring system, you're going to get alarm. You're going to get real-time alarm. So this alarm will be based on your threshold. And this is where it's like I always say to people, you need to take steps when you start to put the monitoring system in place. You can't start to say, okay, I really want to have this parameter to be between 20 and 25, okay? Where maybe you need to start between 15 and 30, and as you go through the process and you reduce the alarms and you weed out the false alarm versus the real alarm, then you can start to tidy up your parameters. But often what you see, you have people that want to go too fast, and actually they get frustrated because they get too many alarms and they cannot action on them. The second thing that you have is you will have SMS and emails that are sent by the system to your various entities in your company, and again, there you need to have some triage, because if you don't put the right profile into that, people are going to be submerged with email or SMSs, and at the end you have this big red light on the corner that is always red, and people tend to ignore it. And then you go back to square one, that your monitoring system does not provide any value anymore. So the third thing that the monitoring system that will give you, if you do it properly, is what we call the trend. So this is like proactively you can see the health of your network, because most likely, unless really, for example, if you have a fiber cut, so you cut the fiber and now you don't have any more signal, if you have degradation from aging of certain part of your network or certain devices that start to kind of not working at 100%, you will start to see health degradation, especially on all digital network with the parameters. And that will allow you with the health and looking at that to have trend and proactively act before the customer is affected. Then the fourth thing that you really get that is actually what everybody wants is the big data. Okay, you get a lot of data from that. And where the art from all the suppliers, regardless if you are homegrown or you are a company that provide monitoring system, is the storage and the mining of the data. And there you're starting to kind of go even at the server level on how fast the server and which architecture do you need on the server to be the fastest in terms of getting the data and getting them presented to a NOC or a technician that is trying to do a repair. So the big thing, the Pandora box that everybody thinks, especially if you go to the financial side of a service provider, is what we call the truck roll. So a truck roll is what is kind of a slang term that we use in the industry, is when you dispatch technician in a truck to go into the field to ever do an installation. So for that, you don't have much to do there. I mean, I know some people have told it self-install, and sometimes it works, sometimes it doesn't, but mostly the truck roll is when technician goes to do repair. So that is often on the OPEX of a company the most expensive part, because you have a human capital, so you need to have a lot of technicians if you want to be very responsive to repairs. And of course, you have a cost associated with that, with the truck, with the insurance, with all the things that goes with that. So if you can reduce the truck roll, then you're starting to have something that makes sense. And the myth that you have when you start to talk about monitoring system is people think, okay, great, we have a monitoring system, now we don't need the technician. Let's make sure that we don't have technician because we have this monitoring system that's going to do everything for us. Well, there's a problem here. The monitoring system does not cancel the truck roll, okay? The monitoring system helps you to have smaller truck rolls, so actually you will reduce your OPEX on truck roll, but you will not make it to zero. It's not possible. Simple reason is fiber is not self-healing today. If your fiber is cut, you need to dispatch a technician with a splicing machine, and you need to go splice the fiber, and that's not going to be done by software. I'm sorry, but it won't happen. So what the monitoring system can do, it can detect the issue before customer detect the issue. And that, I think that's the key, is actually if you are very proactive, is you know that you have a problem, you already dispatched the technician, and it's fixed before any of your customer has been affected by that. The second thing is, especially like, for example, if you take an hybrid, and I have an example on that on the next slide, if you take an hybrid network, is pinpoint the location of a fault. Because, you know, if you have a fiber, if you have RF, if you have the customer, at the end, where's the problem? Is it really at the customer location only? So I should dispatch a fulfillment tech to go to the customer location. Is it on the RF piece? So I should dispatch an RF technician. Or is it on the fiber piece? And is it a fiber running on a cable, or is it a fiber underground? So now I need to send a bucko with a crew that is able to dig to be able to get access to the fiber. And of course, what the monitoring system does is actually it provides you real-time information, and also it tells you when the fault is clear. So actually, as soon as the fiber of whatever problem that you have is restored, your alarm will clear and your NOC will know that everything is good. So let's take a real case example. And again, as I told you, I'm very close to cable TV, so it's a cable TV example. So as you know, on the cable TV world, you normally have a fiber that goes from the head end all the way to the first amp, if you are on a Node Plus 1 or Node Plus whatever. And then after that, you have an RF piece, then you have your customer. So the cable modem is out due to a fiber cut on the primary feed, okay? So the first example is I don't have a monitoring system, so I don't know that the fiber is cut. So my customer goes try to get his YouTube video. That will not be good if you are a cable TV customer to go to YouTube, but that's another discussion. His modem doesn't work, so he kind of upset and he called the customer care line. The customer care line goes to the NOC. Then the NOC start to look at it, and we find out that indeed there is no signal coming back from this specific customer. The modem is unseen. So now they start to dispatch a technician. So what do? First thing is they could do, if they don't think straight too much, we're going to send a fulfillment technician to the house of a customer that can take 4 hours. In the meantime, additional customers are going to start to call. So then now they're going to dispatch an RF technician to go look at the RF cable. And then eventually there's more technicians, so they know that there's multiple parts of the RF that is affected, not only one node. Then actually they say, okay, well, we should send a fiber technician. I know that we have a few service providers on the line, and I know that I'm exaggerating to see the problem. Now let's look at it if I had a monitoring system. So the monitoring system would have detected that actually the node is out and there were no modem coming back found this specific node. Based on the fact that the monitoring system has an active RTFS system attached to it, he knows the fiber, so he can tone the fiber or send a pulse to the fiber, verify that it is a fiber cut because it's attached to the mapping system. So now he knows that I have a fiber cut. I know where the fiber cut is. I know if it's underground. I know if it's on a pole. So I can dispatch the technician. And actually, within a few seconds, the alarm has already been processed and dispatched the right technician that is already en route. By the time your first customer calls, you can already tell them that actually, Mr. Customer, thank you very much. We are aware of the problem. The technicians are en route. We have an ETA of restoration within 20 minutes. And that makes you a very happy customer. So right there, it's hard to say what is the price tag on that. Well, the fact that the customer is not going to turn to another service provider, maybe there's a big price tag on that. And if you consider that was a full node that was out, that's 500 customers. So you technically have not lost 500 customers. So I think it speaks for itself when you look at how much you pay every month for your service. So the next thing is most up to date, a lot of monitoring systems were what I call reactive. So actually they look at the network, and then when something happens and something breaks, they detect it and they report it. Well, the problem with that is actually the fault already occurred, meaning the service is already affected, the customer is already disappointed, and then now you have time to repair, and that's lost revenue. Depending on the service agreement that you have with your customer, it could be lost revenues. Now, if you have a proactive monitoring system that is able to monitor the health of your network, then you can actually know before it goes out that actually your network is degrading, and you can do proactive maintenance before the fault actually occurred. And that is the best, because if you are able to find that your network will have a problem eventually in a couple of days, then you can fix it without disrupting any customers, and you don't lose any revenue. And for that, I have an example here to kind of put the picture. They say that the picture is worth 1,000 words, but it takes us 10 times more hard drive space. So here again, a cable TV example where I have a head end, and I have a network that is hybrid with fiber and my node and so forth. And here you can see on the little map here, I have a couple of modems. So these ones are not modems that are offline. They are red because their health threshold is degrading. And you can see that based on the pocket where they are, is actually they're all coming from the same node. So I know already if I take this data in, that actually I have a problem on the feed that goes to this customer. It's not something local. It's something that will affect many customers. So based on that, by doing proactive, I can dispatch a crew. And based on the problem, of course, I didn't go into the detail to see why they were red. It could be the MER that is dropping. It could be the equalizer that is equalizing too much and so forth. But by looking at all this data that you have available to you, you can actually have a pretty good idea of what is the problem and who you should send to repair the thing. And that is the beauty of that. And actually, a lot of service providers now are starting to do that, and it's very efficient. Their network is getting better and better, and you're almost never out. So with all that is you're getting all this data. And, you know, what you can do with the data, you can let them sit on a hard drive and do nothing with that, and it's probably not very good because this data can be very variable. So if you monitor without the proactive component, you will have what I will call small data, because technically you only keep what has been happening and only the alarms, and you already know that you have an alarm, you already know that you have a problem. Then actually you repair it and you process it. You can keep it. Normally we recommend a 72-hour keep. That's just a few terabytes, just in case that you need to go back and so forth. If it's a business customer, you want to probably keep it for 30 days, but still, that's still very, very small. When you start to look at monitoring with a proactive component, you have big data, very, very, very big data, because now you not only, let's take a simple example of a service provider that has 16,000 nodes going to customers. You have 16,000 probes. That is pretty small compared to 9 million customers. 9 million customers, that's 9 million probes that you can actually have, bringing you back data. But data is just humongous, and you need to process it. not only that, you need to actually keep the data for referencing model, because what you want to do is actually with these pros that you have in your network, you want to do birth certificates. So you want to be able to, okay, I'm doing an install, I'm extending my network, this is the new devices that we put in the network. You want to kind of take a snapshot of how they're performing, what are the key metrics on your devices at the time of install when you know that everything was working. So when you start to see degradation on your network, you can compare the data. So the problem with that, it's a lot of data to keep. And now you need to start to have big data farm. That's why everybody's talking about the cloud. I mean, we've been doing cloud for such a long time. It's just now people realize that we've been doing cloud. And this data needs to be stored on servers, so you need to have big data centers to be able to keep this data. The other thing, too, is the data needs to be analyzed without affecting the ongoing monitoring. So that means that you need to have additional server that grab the data, copy it over, analyze it, process it, and do the trend analysis on that. And the big thing is a computer, although I know that certain people say that computers are going to overtake the humans pretty soon, it is still pretty ones and zeros and pretty basic. So that means for a computer or a server or a piece of software, we can only tell you that I have this series of ones and zeros, and I was expecting this series of ones and zeros. Now, does it tell me that I have an amplifier that is going down? Does it tell me that I have a bad tap? Does it tell me that I have a bad drop? Does it tell me that I have a bad SFP? No, it does not. It just knows that there's a problem. So what is very important if you start to do this type of monitoring with proactive intelligence, it's to have a human piece that can feed back to your monitoring system, say, when you see this trend, this is what the problem is. When you see that trend, this is what the problem is. Because good news for the techs out there, not everything can be solved by computing data. You still need human intervention. So this is why I say that you need to send your monitoring system to school. It needs to be able to learn from what it detects and have a resolution. So that's actually what some people start to think about, putting artificial intelligence in monitoring system. And I know that when you start to talk about artificial intelligence, everybody think about these robots that are being designed by Google that's going to take over the world. But actually, artificial intelligence has been in place for a long time. This is actually artificial intelligence means that you tell your system to think for itself and to be able to derive information from the metrics that it measures and give you an intelligence, plain English, if you speak English, words that can tell you this is the problem. And the big thing with a monitoring system is it's not something that you kind of, you purchase it, you install it, you commission it, you put it on, and it's there. A monitoring system, contrary to what a lot of people think, needs to be maintained. It's like if you're in a relationship. You need to feed it information. You need to pay attention to it. You need to look at the parameters and how they go and the evolution in your network. So it's a full-time job. And that's why sometimes people get frustrated with monitoring system, because it's a big thing to swallow for any service providers if you want to get the best buck for your investment. Now, you can say we have it, and then we can check the box and then forget about it. That won't work. So to finish, I'm going to do a little bit of a self-plug because I can, because I'm the one talking. And although, I try to stay very out of what VX does, here's a slide of what VX has been doing for the last 8 years. We started from a very small little handheld, and now what we have a platform that is called Vision that started as a very cable TV-centric architecture, but now is actually any service provider-centric architecture that can integrate the workforce, that is your technician that goes out with field meters, the monitoring, that is can be RF, fiber, or Ethernet, that can also integrate the P&M piece of it, meaning P&M is the proactive maintenance and getting the data from your devices. And all that integrated into one platform that you can have access on the web, on a tablet, on a phone, on your field meters and so forth. It's integrated with the mapping. We work with several mapping companies because we are not a mapping company per se. And when you're starting to have this type of integration, you really start to get your money back on your investment. And you can see that actually your network is becoming much, much better, and your customers are feeling that actually the network is worth what they're paying for. And on that, I think I'm right on the timing that we can take the question and answer.
Very good. Yes, you are correct. Thank you, Cyril. It is indeed time for the Q&A portion of the proceedings. As a reminder, if you have a question for either of us, all you have to do is open up your Q&A screen if it's not open already. Type in your question, hit the submission button, and let's see. I see that a few of you have done this already. Let's see. We have a question on out-of-band monitoring. So I'm guessing I'm going to direct this to you, Cyril. Basically, the question is there an argument for out-of-band monitoring? For example, a 4G telemetry modem monitoring an optical hub so status is available if the fiber or node is down.
Well, that's actually, I will say the out-of-band or using devices, there's a lot of things that can be done and with this type of devices. So the telemetry is going to tell you that, okay, now I have a modem with a 4G thing that's run on battery that is attached to my optical node in the street and so forth. So if a node goes down, meaning like the device itself goes down, the 4G telemetry modem is going to report that. So that's a great step to know that your node is down. Actually, I could say that you could do it even without putting that. You can just do it by having querying the modem from your customer. They're already there. You already purchased them. I mean, your customer already has a modem, and you can actually from there know that your node is out. The big thing is now that your node is out is do you have devices that are going to be able to tell you where the node is out? That's really the problem because, okay, now I know my node is out, so I can go back to my first example and go back to the guy that you're going to send 3 or 4 technicians out, and they're all going to look at some piece of a network to see what is out. As if you have the right tools already in your head-end or central offices, you can query the network very quickly and find out that actually this is where the node is out. You know, for example, if you have an RTFS system, RTFS system means for remote test fiber, and you know that you have a node with problem, you can shoot a trace into your primary feed, and then you can see if your reflection returns back that is 4 miles and your fiber is 4 miles, and you know the fiber is not cut, so it's already an RF problem. So you already know that it's not a fiber cut, it's an RF problem. So then you can already dispatch the right guy. But it requires to have an RTFS system. Now you can say, okay, great. I don't want to spend money on an RTFS system and just buy a couple of OTDRs. Well, now you need to have a technician that has OTDR expertise that is going to know where to plug in. Okay, it needs to go to the head end because we all know now that most of the central office and head end are unmanned because there's not enough bodies to support them. So that means probably the guy needs to drive 2 hours before he gets to the head end. So that means you already have lost 2 hours before you even know what problem you have. So yes, I mean, this is a value, and actually it could be added to a system, but I don't think it's completely the full solution.
So here's a question, and again, if you want to put a question in the queue, we've got a couple of more minutes. Just type your question into the Q&A box, hit the submission button. This question comes from someone who wants to know about network monitoring and multi-vendor networks. Are multi-vendor networks a particular challenge for network monitoring systems, and if so, how do you solve it?
So I'm not sure that I understand the multi-vendor networks, meaning like when you are, for example, a content provider and you provide your service to several service providers, and actually they're always telling you that what you're giving them is not good, and you're telling them that actually what you're giving them is good. That's their problem. It's always a finger-pointing thing. Or is it you have, for example, a multi-vendor network where you're going to have, let's go back to my beautiful cable TV world, where you're going to have Cisco's and you're going to have Aris and you're going to have modems from plenty of different vendors and so forth, and you're going to have fiber nodes from different vendors. So if that's a question, well, technically any monitoring system should be able to adapt to anybody that is out there. And actually, the question was actually addressed directly at Vision. Vision is vendor agnostic, so we don't really care which vendor you have. We work with all of them. Of course, we have the one that we prefer to work with because they're nicer, but I will not say that.
So speaking of challenges, maybe as the last question, what do you see as sort of the biggest challenge for people who are trying to establish an effective network management system, perhaps in the context of some of the things that I brought up?
Well, if you are about to deploy, or if you are thinking about deploying a network monitoring system, I would say first of all is take your time to think about it and start to have a very stringent document on what you want to get out of a monitoring system. The reason for that is often I see people that they start with one idea, but it's something that is very condensed, and then they evolve into adding so many parameters to the question that actually you can never make it work. So if you have knew that from the beginning and know that you were about to be going into this depth of analysis, then you will have had the right resources in order to be able to support that. The second thing is what you will find is this is where you're starting to have the debate in every service providers is the network is normally an operation thing. So actually the network is maintained by operations, and they are the one that want the monitoring system because it will make their life easier and being able to be faster at what we need to do. The problem is it's going to involve a lot of different pieces in the company between the IT world, because now you're going to have a bunch of servers, between the network operations, because you're going to have to have all these devices that you put in the head end of central offices. So my recommendation is make sure you involve the right people up front, because you're going to go to a vendor, whoever it is. Hopefully it's VX, but it could be. There's a lot of great people out there besides VX that do that. And they're going to tell you something, and maybe your company has a policy on servers that doesn't match a monitoring system. So you start to go down a road, and then by the time you want to press a trigger of purchasing it, you can't because your IT team cannot support you. And of course, there's after that the security that is associated with that. Now you're putting all these probes in your network. You have a security component that is very important because, as you know, everything gets hacked every day. So we need to be very careful with that.
Very good. Let's see. I see more and more people are submitting questions. Again, if you want to join the queue, just type your question into the Q&A window and hit the submission button. Here's someone who points out that a lot of operators are, as you're doing mergers and acquisitions and whatnot, or you have an old system you're looking to replace, you end up with either an old system that needs to be upgraded or a network monitoring system that you'd like to integrate into the one that you're using. How do you do that network monitoring integration?
Well, normally, so if you divide that into steps, if as a vendor of monitoring system, if you have designed your system properly, you should have actually what I call a little compartment of resources. And then you should have an API or a bridge that talks to your system. So what we have seen on the VX side of the things is actually our alarms are always funneled to a NOC, and the NOC didn't wait for VX to have an alarming system. So actually we push the alarms through a NOC and to a platform, and there's a lot of platform out there, but there is standard for that. You can use SNMP traps and MIPS that are mostly what people use. And then after that, you will give a common data into the NOC so they can do the alarming and so forth. When it comes to do the proactive and the intelligence and the analysis, that normally reside on the vendor side because it's so proprietary and so there's so much IP into that most people don't want to share that with other people of being scared to be having their IP stolen. So normally that will run on a separate platform, but since everything is web-based, it doesn't really matter. You can have one browser open with your NOC and one browser open with your vendor-specific thing.
So speaking about kind of hybrid environments, I guess the other dichotomy, and you kind of touched on this a little bit in your presentation, is sort of the homegrown network monitoring capability versus a vendor monitoring system. Now, obviously, I'm sure you would hope that everybody would go with a vendor monitoring system, but can you talk a little bit about one versus the other, and perhaps how, again, maybe how the two potentially can complement each other if that is indeed the case?
Well, I think of course, it depends the size of your company. I mean, if you are a large number one supplier like Comcast, you definitely have resources and you don't have much limitation on doing that homegrown. And actually, they have some very good solutions that they have developed in-house that are quite amazing. But if you're a smaller player, and there's quite a few of smaller players, is the homegrown is often doing an homegrown monitoring system is, when thing goes bad in terms of revenues and so forth, that's the first thing that any CFO part of his name will do. That's the first thing he's going to can and put to the trash. So now you get a monitoring system that may not be completed, and then you have nobody to maintain it because the one guy that knew it all is gone because he was not part of the grand plan to make money. So that's the danger of that, because often these things are not done, with the same way that the vendor will do. A vendor will provide training, will provide support, and as long as the vendor exists, this system you will be able to get support for that. So that's a big difference. But I think also this, everybody has his own specifics, and I think like if you are a vendor and you try to shove down the throat of a customer, say that's the way you need to monitor, and this is the way, and we're not going to change it, that's wrong. You need to make sure that you understand your customer and what they're looking for, and there's always some customization. So now the customization can be done from the vendor side or it can be done homegrown. And actually, the part that I've seen working the best is when you have a mix of both. So the customer does take some ownership, and they're doing some development, but the vendor support them all the way through to make sure that you have the best experience at the end of it.
So along those lines, I guess if you're trying to make the case to management that you should bring in some additional network monitoring capability or some out-of-house expertise in the form of a network monitoring vendor, the whole question of return on investment comes up. Is there a way to kind of quantify return on investment in network monitoring systems, and is there kind of an average ROI for network monitoring?
Well, that's an interesting question on when you do that. And there's the automation part that actually you don't need to do manual labor to get the information anymore, like some customer used to do before they get the monitoring system. So that's very easy to quantify. You have so many bodies doing so many measurements for so many hours at such price. That's how much I'm going to save on a yearly basis. And with that, you can definitely have a quick idea of, okay, I'm going to spend $1 million. It was costing me $500,000 a year. 2 years, I get my ROI. Now, after that, when you start to do ROI on customer experience and the fact that you don't lose any more customer, it's actually much more difficult because it takes time. You can only see that 2, 3, or 4 years after you have installed the monitoring system and see that actually you're not losing customers because your service is good. And then the problem that you have, Stephen, is what you were talking on at the beginning of the thing is, 5 years down the road, my technology will evolve. 5 years, if you look at MSOs, we were doing 3.0. Now we're doing 3.1. Where am I on the 3.1 monitoring, and do I have a monitoring for 3.1. So normally what I've seen and what I tell customers is you should look about 3 to 5 years for a ROI in terms of monitoring system. After 5 years, the system will make money for you.
Very good. And with that, we have come to the end of our program today. If we didn't get a chance to answer your question just now, or you want to ask one offline, or potentially you're watching this on demand, you can reach either of us via the email addresses that you should see here on your screen. Now, if you haven't already, you might take this opportunity to download the slides from the resources folder while I remind you that, as I mentioned at the start of this event, if you know of someone who should see this webcast or you want to see it again yourself, this presentation will be available on demand in about 24 hours or so. We'll send you an email with a link directly to the archive version of the webcast, and the archive also will be accessible from our homepage at btreport.net for that webcast button right above the main navigation bar, as I mentioned. And with that, I'd like to thank Cyril for sharing his expertise at VX, for their help in making today's event possible, and of course, you in particular for attending. I hope you'll join us for our next BTR webcast, which will take place on Wednesday, September 30th. Please keep your eyes peeled for more details upcoming on that. Until then, have a great day, and goodbye.